Now that you know about the purpose of a distributed batch system, let's talk about the user interface and how you'd actually go about using it. Now, there's a wide variety of distributed batch systems out there, both commercial and open source, but they all have the same underlying concepts in the user interface. So no matter where it comes from, you're going to see the same operations. The first operation is going to be to query the system status to see what sort of machines are available and what their properties are. And then when you want to run a job, you need some means of describing and submitting a job to the system. And once the system has accepted the job, it's going to return some kind of job ID in the form of a number or a unique identifier so that you know how to refer to it later. You should be able to query the job status to see if it's running and where it's running. If necessary, you can remove a job so that it doesn't run at all. And finally, when a job has run to completion, you should get some kind of notification, whether by email or SMS or just creating a file. Now, it's hard to talk about these in the abstract, so we're going to use one batch system as an example. And this example batch system is called HT Condor, which comes from the University of Wisconsin. And it was first created in 1987, but has been in continuous development ever since then, supporting all sorts of applications in science and engineering. And you can learn lots more about HT Condor by going to the URL on the screen. HT Condor is used in a wide variety of places in the United States and around the world. And if you like, you can check out this interesting online map that shows you many of the places that are reported on a public network. So on this map, each square shows a unique HT Condor installation. The green squares on the map have up to 10 hosts. The purple squares have 10 to 100 hosts. The violet squares have up to 1,000 hosts, and the red have over 1,000 hosts. So you can see there's quite a few large installations out there. In fact, there are many, many more that are not reported simply because they're not on public networks. So HT Condor is widely used around the world. Now, I'm not going to go over installing HT Condor because that varies quite a bit between sites and locations, but I'm going to assume you have access to an HT Condor installation, and will describe the commands that you would use to interact with it. So the first thing that you might want to do is to query the system status. And to do this, you're going to run Condor status. And it's going to give you a big display on your terminal here that shows all of the machines and what they're doing. Over in the left column there, we have the name of the machine, and then the operating system that it's running. And you can see in this example, we have both Linux and OS X, that's Macintosh operating systems. And it also tells you the architecture. So here we have x86-64 as well as 32-bit Intel. An interesting property of an HT Condor system is that you can have different incompatible machines all managed by one pool, and Condor will figure out how to assign jobs to the machines that are compatible with them. The next column over here shows the state, and that shows you who's using that machine right now. If a machine is unclaimed, it means nobody's using it. If it's claimed, it means it's been assigned by the batch system to run a job. And there's also this interesting owner state. If it's in the owner state, it means somebody's actually sitting at the machine and using it actively, and so it's not available for use in the batch system. This is a legacy of the fact that HT Condor was originally designed to harness idle cycles from workstations, even though today it's used more to harness clusters. Over here we have the load average, which comes straight out of the Unix load average. So 0 means the CPU isn't being used at all, and 1 means one CPU has been completely used over the course of the last 5 to 10 minutes. 2 means 2 CPUs has been used, and so forth. And then finally we have how much memory is on the machine and how long it's been in that particular activity. Also at the bottom it gives you a summary of all of the machines in that pool. And again, in our example here, we have over 2,000 total machines. And you can see that most of them are x86-64 Linux machines, although we have a smattering of other machines and operating systems, including OS X and Windows. Now we're going to submit a job. And we do that first by describing the details of the job in a file. In this example, we've called that file myjob.condor. Once you've created that file, then you simply enter condor submit myjob.condor. Passes the information over to Condor, which thinks for a moment, and then returns back a unique job ID for that thing which you just submitted. Now, a side note, Condor here calls a cluster for a group of jobs. It's not referring to the cluster as a whole. That's just some old terminology. So when you see that, just think job instead. Now, what's in that submit file? Let's look at a simple example. In a submit file, you describe the thing that you're going to execute, as well as any additional information Condor needs to know about the context. So here, we're going to submit an ordinary Unix executable, and we have to specify what universe this lives in. You can think of universe as just sort of a category of jobs. And in this case, the vanilla universe means standard Unix executable. We have to specify the program to run as an executable. In this case, let's assume it's a simulation of some kind. And then the arguments that we're going to pass to the simulation. In this case, let's suppose we're specifying the temperature and the molecule to simulate. We have to specify where the standard output file is going to go. That's going to be in a file called sim.output. And additionally, we're going to specify a log file, which is going to give us some additional details of how that job ran. And then finally, to run one job, we state Q1. If you wanted to run 100 jobs, you would say Q100. So we submit that job, we get a number back. And now to check on the status of jobs that we've given to Condor, we run Condor Q, where Q is short for the queue of jobs. So this display shows us all the jobs currently queued. At the moment, there are 3 of them. And the highlighted one, 45524, is the job that we just submitted. This display shows the owner of those jobs, when they were submitted, and their current status. Some of the jobs are marked as R, which means they're currently running. I means idle, meaning that it's sitting in the queue and Condor hasn't found a place for it to run yet. And then the size here shows the memory consumption of that job as it's running. Because this job is idle, its memory consumption is 0. Now there's some other states that a job can be in, and they're summarized down here at the bottom. If it's completed, obviously it's done. If it's removed, it means it's been marked for removal, but it hasn't happened yet. If it's idle, it's not running. If it's running, it's running. A job can be held if something went wrong with it, and so Condor kind of sets it to the side and says, I think you need to take a look at this. And a job can be suspended if a machine becomes temporarily unavailable for a short time, but is expected to become available, and so the job can keep running. Now, if we decide we don't need a job anymore, we can remove it by running Condor RM and the job ID. So Condor will take that and come back pretty quickly and say, job 55524 marked for removal. Now, an interesting note is that if you do a Condor Q immediately after removing something, you're likely to see that the job is still there, but it's marked as in the X state. If you wait for a while, it'll go away. Let me explain why that happens. Turns out that removing a job is potentially an expensive operation. It's not enough to simply discard the job. Condor has to go out and find out where that job is running, tell the machine to stop, maybe clean up some files that are out there, remove its local records, and especially if you have a lot of jobs to remove, it may not get to that right away. So instead of making you wait for all that time, when you do a Condor RM, it immediately marks the job as X and returns, so you can get back to what you're doing. And then in its own good time, it will go out and do the work of actually removing the job. Now you recall, in that submit file, we specified that we wanted a log. And so this is an example, a short example of a log that might be produced throughout the lifetime of a job. So here, the first record says that the job was submitted from a given host and gives its IP address. And then after about a minute, Condor places that job on a machine and it starts running. So we see an execute record. After a while, after the job has been running, Condor measures its memory consumption and reports that back. So that's the image size right there. And then finally, we see that the job is terminated at 21:33. And after the job is terminated, a little record comes back and tells us about the CPU consumption and the I/O behavior of the job. Now, you don't have to turn this on, but I find this to be a very effective debugging and teaching tool because it tells you about everything that happens to a job, and especially if you have something that's long running or does something expected, it can go a long way to explain everything that's happening in the system. Let me point out one other thing here which is going to become important. You'll notice here that the job was submitted at 15:43 and 49 seconds, and then it was executed, started executing at 15:44 and 31 seconds, a little less than a minute later. So what you'll find is when you give a job to Condor, sometimes it starts running right away, sometimes it takes a little while. It can often take 30 seconds to a minute, and that's simply because there's a whole lot of stuff going on. It can take a while before Condor gets around to executing your job. We call this the 30-second rule of thumb. When you're estimating how long it's going to take things to happen, you should estimate it takes about 30 seconds to dispatch a job in the best case. Sometimes it's faster, sometimes it's slower, but there's a lot going on in a busy HT Condor system, and your job isn't going to start running right away. Now, I've given you just a quick overview of the commands that are useful in HT Condor. You can go and check them out in the HT Condor manuals and the website and so forth. There are other batch systems out there, and another common set of commands that you might see come from the POSIX standard. And there's the same set of operations here, they just have slightly different names. So in the POSIX standard, to submit a job, you run a command called qsub. To query the queue status, you run qstat. To query the system status, that is the machines available in the system, you run qconf, and to remove a job, you run qdel. Same concepts, different commands. There's a couple things that you need to remember as you use these commands in order to manage a large amount of work. The first is that jobs are asynchronous. Now, what does asynchronous mean? Asynchronous means without time. That is to say, once you submit a job, you don't know exactly when it's going to run. It might run right away, there might be a delay, it could be an hour, and you can't really say anything for sure about that job until it comes back and reports completion. Now, because of that, if you run multiple jobs simultaneously, you can't make any strong statements about which job is going to run first. If I submit 10 jobs, there's no guarantee, in fact, I can't even expect that it's likely that they're going to run in order from 1 to 10. They are asynchronous, meaning that they are concurrent and independent. We can't say anything about how they're going to run until they finish. This may sound inconvenient, but this is how we're going to get high throughput. You'll recall from the last lecture how I explained that the system is very dynamic and has many gaps and many fragmented areas. Well, Condor is going to do its best to fill in all those areas with your jobs, and it can do a best job if it is flexible in how it runs the jobs and in what order it runs them. So the result is the system is high throughput, which is to say, over the course of an hour or a day or a month or a long period of time, you can run a whole lot of work simultaneously, and you can complete a lot more work than if you had one computer. Now you have to be careful. The system is not high performance. Remember that 30-second rule? If I submit a job, it's going to be at least 30 seconds before it gets started, and so running one job through Condor is probably going to be slower than running it on one machine. But if I run thousands and thousands of jobs, I'll get much higher throughput than if I had just one machine.